Good morning. It's great to be here and it's great to see you all here and it's fantastic to see how buzzing the event actually is. Uh, Limiting climate change is something we all want to achieve. Uh, Rather than talking about long-term goals or lofty ambitions, what I would like to do in the next 30 minutes is talk about practical solutions. Ways in which we actually can make sure that companies can reduce their Scope 1 and Scope 2 emissions at scale. Getech is offering four types of solutions that help companies across the world with proven technologies by unlocking the Earth's subsurface potential. What we do is actually we screen for global portfolios or opportunities across the world, and then for the most high-graded opportunities, we're able to actually conduct feasibility studies to help you analyze what the right investment decisions are to help you on your decarbonization journey. But before going into all that detail, let's step back a little bit. The focus on decarbonization has never been greater, and I'm sure you're experiencing the same. Industry has a very important role to play in this. As you can see from this pie chart, around 30% of the total global greenhouse emissions are actually coming from industry. So that means that those in industry in those areas, I'm sure, will feel pressure to decarbonize from customers, from shareholders, or from many different other types of stakeholders in order to make progress in this. And it might be that you're actually making some initial steps in this and start realizing, okay, make good steps forward, but it is getting harder to make the next steps. Or you're actually seeing this as an opportunity. You want to play offensive because you realize there's a lot of value pools to be had if I'm an early mover in this. But the question is how to actually do this in practice. And the challenge is certainly there because it is not easy. And you're not alone. There are many companies struggling, trying to make that connection between the long-term aspirations and the practical implementation of these goals. A recent study of Ernst & Young indicated that only around 5% of all the FTSE 100 companies actually have a credible decarbonization plan in place. And it's understandable because it simply is not easy. If you want to make sure that all your heat and power is actually net zero, where are you going to get it from? Yes, solar and wind certainly can help quite a bit in all this, but the grid is congested, and of course, well known, solar and wind aren't always available. If you want to store your excess CO2, where actually can you do that? Do you need to go offshore and be part of some of those very large clusters, or are there potentially other solutions? And with the volatility in energy prices, which we're seeing given the volatility in solar and wind, is there a way to make sure that you actually can get more control? Because, of course, the goal of decarbonization and getting to net zero is important, but we also need to look at the profit bottom line. And if you're actually in the manufacturing business and you require input materials, you also have challenges there. In particular for the critical minerals, you need to find ways of getting more certainty and securing your supply of these minerals. So the challenges are significant, and hence let's look at four practical solutions. The great thing is that the Earth has untapped potential. The Earth offers us at least four different ways in which we can actually help you on your decarbonization journey. First of all, with geothermal. Geothermal allows us the possibility to capture the energy in the subsurface and thereby heat and or power your business. Carbon storage. In those cases where you can't eliminate or mitigate your CO2 emissions, so-called hard-to-abate CO2, there is plenty of opportunities to store your CO2 safely underground. For critical minerals, we can actually locate many more of the minerals which you will need in order to secure your supply line. And fourthly, with regards to energy storage, it is possible to preserve that energy for the times, the green energy, for the times you actually need it most. So what I would like to do in the next session of this talk is actually step through those 4 elements in a bit more detail. I'll highlight the benefits, but also talk about some of the practical implications and considerations which you'll need to keep in mind in order to see which of these and how to actually implement them for your business. So let's start with geothermal. Geothermal is a clean energy source which is available 24/7. And that actually means that it is very reliable. It can therefore be an excellent base source for your energy, providing that confidence that you have that energy all the time. But given the fact that geothermal energy also can be switched on, switched off, it can also be a perfect source for managing your peak demand. Secondly, geothermal provides you with a plant close to your facility which provides incredible security. And security in the form of price, because you know the plant is there and its running costs are fixed, and thereby you can really make forward plans on what your price will be. And of course you don't become dependent on the grid anymore. Talking about cost, geothermal energy is actually cost competitive with other green solutions. A recent study by Lazard, some of you will be well familiar with it, highlighted that the cost of geothermal when compared to solar and wind, and adding in the cost of batteries for those latter two, because the energy might not be available at the moment you need it, indicate that geothermal is cost competitive. So that's really a big step in the thinking, which makes this a much more attractive solution than in the past. Other further consideration for geothermal is, of course, the footprint of it is really small, and operating costs are low. And when you have a plan in place, it can run for decades. So, in summary, geothermal fits very nicely as a solution in the middle of the energy trilemma of finding the energy which is affordable, secure, and green. But of course, those are all the benefits. Let's talk and look a little bit in more detail about this. There are other considerations to take into account whether or not geothermal is good for your particular situation, and if so, how to approach this. For geothermal, there are 3 elements to keep in mind. The subsurface, what characteristics are there, what are your specific, the customer specific needs, and what kind of technologies are there available. And really starting off with the customer, it is important when considering geothermal to understand what do you want to use it for. Is it for heating or cooling a building? Is it for heating a whole district? Is it process heat? Or are you looking for electricity? And depending again on the subsurface, it might be easier or more challenging to achieve that. But the third element is critical here, is understanding all the different type of technologies which are available. And again, that's what we can help with, understanding that subsurface, combining it with the technology in order to meet your specific needs. Another point which some of you might be thinking, geothermal has been around. What's different? Well, actually a lot is changing, or has changed already. Technology advances are very important, which make it cost competitive, as I spoke about before. But moreover, new technologies allow geothermal to be applied at places where previously was not possible. Think, for example, about the closed loop technology, such as brought forward by our partner company Ever, but also the possibility to extract lithium, which is, of course, a very valuable mineral at the same time as you're extracting the heat from the subsurface. That, of course, can be a huge value booster. We at Getech are agnostic to the type of technology. Yes, we have partner companies for different type of solutions, but we thereby can help you to understand the subsurface, the different types of technologies, and advise you on what might be the right geothermal solution for you. Let's move to the second subsurface solution. When you can't avoid CO2 because it simply cannot be eliminated from the process, you need to start thinking, is CO2 a potential solution for me? And as was already mentioned in the previous talk, it is a very important part of our global journey to net zero. Reasons for that are, first of all, it is a solution which can handle enormous amounts of CO2. It is a proven solution. Let's start maybe with that point. We see that there are already CO2 sequestration operations ongoing for decades, either onshore or offshore. Offshore in Norway, the Sleipner field is a well-known example, being stored safely and successfully there. Same in Canada, Quest opportunity running for a pretty long time. And it can handle really large quantities, and that's really what we need as well. We need at least, in certain predictions from the International Energy Agency, around 20% of the total amount of CO2 which we need to reduce in our system in order to reach net zero needs to go into carbon capture. And talking about specific sectors where it's most applicable, think, for example, about cement. Cement is after water, the most used product in the world. And you can, if you think about it, you can imagine it. Everything, everywhere in the world is using cement. And it is a process where actually by the creation of cement, CO2 is coming free as part of the process of simply making it. So it's very difficult to abate. So that is a perfect area where you can start thinking about a sector where CCS is very applicable. But also the ones which were mentioned earlier in the previous talk, about BECCS, so bioenergy being burned in order to create energy, and storing the CO2 from that creates a negative carbon footprint, as well as direct air capture, again, that needs to be combined with CCS in order to make it negative and hence attractive for us. Some of you might be thinking, okay, that's all nice and dandy in theory. What about the cost implication of this? And again, what is important here to look at is from an end customer point of view, a societal point of view. A recent study, for example, indicated that if you want to apply CCS on, let's say, building a bridge, and you capture all the CO2 which comes free from the cement and the steel production, you can, total cost of the bridge increases by just 1%. But at the same time, you can reduce the total CO2 footprint by 50%. So it is becoming more and more cost competitive, of course, combined with helps which we see in Europe from the carbon border adjustment tax, the ETS scheme in Europe, or IRA in the US. So CCS, again, a very important potential solution. What about the practical side of it? Many independent studies have indicated, including from the recent one issued by the UK government, that CCS is safe. Next to the fact that we, of course, already have been doing it for decades, further highlights the point that it can be done safely, provided the right location is chosen. So we need to understand the subsurface in order to find those locations where CO2 can be sequestered for thousands of years to come. The good thing is that companies, including ourselves, Getech, have a lot of experience with understanding where those places are, because the storage of CO2 depends on exactly the same processes in the petroleum industry, where you need to understand how fluids, including then gases, move in the subsurface. Where is the porosity? Where can it actually flow to? And where can it actually be trapped? So we can actually leverage our subsurface data, our solutions, our tools, our expertise to help you find potential good locations to store it. We can help also if there's still uncertainty with schemes to maybe obtain additional subsurface information, geophysical methods to help you determine if a location is right. And also after the CO2 has been injected, to monitor the site to make sure that it is actually, the CO2 stays where it is expected to save. One point to consider and to highlight here, as I maybe also pointed out a little bit earlier, is to think about where to store that CO2. A lot of focus in Northwest Europe is on cluster developments, and they indeed have the benefit of scale, but they also bring a lot of complexity. It requires a lot of technological complexity and sometimes even more difficult, the commercial, the partnering complexity, which makes it difficult to get these projects off the ground and up and running. An alternative, which we are seeing in other places of the world already happening, and we are happy to help with investigate, is actually much smaller stores directly or very close in the vicinity of your emission point. So you can start thinking, can I actually store, if I have a factory which is producing CO2 which I can't mitigate, can I store it directly below the place where I have that factory? And that might be potentially a very attractive alternative. Let me move to the third subsurface element which actually can help as part of the energy transition. The dependence in the energy transition of critical minerals is without doubt. Some 70 to 80% of the cost of renewables actually goes into the sourcing of these critical minerals. And there is a very big gap between the aspirations which we have and the actual availability of these critical minerals. So it is really important to find ways of securing that gap. And just to give you an example, humanity, since its inception until now, has produced 700 million tons of copper over all those thousands and thousands of years. In order to make the energy transition happen as we would like it to, we need to get the same amount, so another 700 million tons of copper in the next 27 years. And that is an enormous increase of activity. On top of that, the current existing mines do not have the amount of minerals which we are looking for. So we need to start looking for new mines in order to find those critical minerals which we need. And as you can see on the bar chart here on the right-hand side, you see for two different scenarios, a more conservative and slightly more aggressive one, the increase in percentages of all kinds of critical minerals which we need to start locating. And that clearly is a challenge. On top of that, we have the challenge that we also want to have the security of supply from a geopolitical point of view, because not all places where you might be able to find a certain resource is where you want it to be. Think, for example, about the recent announcement of naturalization of lithium mines in Peru. That can be quite an issue. Thirdly, if you are looking at your supply chain, you also need to start thinking about the ESG impacts. Of course, companies become more and more impacted by what their full supply chain is, deemed to be responsible for that. So if you are, for example, getting cobalt off the Democratic Republic of Congo, where we're all seeing the horrible pictures of children hand digging cobalt out of the ground, that's not what you want to be involved in. So there are really good reasons, multiple which I just mentioned, to actually start thinking, what can I do to secure my supply? And actually, quite a few companies are really moving in this direction. I would say nearly every week at the moment, we see a car company announcing that they actually are moving upstream because they want to secure their supply, being it lithium or other resources. But it's not only those companies. Also, companies like Siemens are moving further upstream to secure they got a supply of their natural resources, in this particular case, and to build the windmills for the energy transition. So all underlying this, again, is the need, the ability to understand where you can find these critical resources in order to secure your supply line. And again, as I mentioned, Getech has decades of expertise in locating natural resources. And that's also what we can do for these critical minerals. We have the ability to generate up to hundreds of millions years in the past, the specific paleo conditions, the topography, the climate, etc., to specifically find those locations at the Earth at a particular point way in the past where a certain type of mineral was deposited. And that allows you to start exploring and developing for these. Then getting to the fourth solution, energy storage, another key element. And the increasing amount of intermittent renewable resources which we are bringing into our energy system. And of course, the consequence of the fact that these intermittent resources are not always available causes volatility in the system. At the moment, that volatility is managed or mitigated by coal and gas power plants which we have, and clearly we want to avoid that. So we need to start thinking of different kinds of solutions which still ensure that our energy system has the flexibility, stability and reliability which we're looking for. And we're moving there pretty quickly because in the EU, for example, by 2030, which is not too far away, the expectation is that the energy system is already for 70% coming from reliable resources. So we need to start finding solutions for that and also start looking at what the benefits are from energy storage. So first of all, and a very important driver is actually to manage cost. If you start using energy storage, you can ensure that you actually capture the energy, store the energy at the moments when the energy is cheap, i.e. the days there's a lot of wind and a lot of sun shining, and use that energy at the moments, of course, when that's not available, and thereby be much more cost competitive. A second point is that you can increase your reliability of your system. Storage provides that uninterrupted source of energy for your operations. And as we're seeing in other countries around the world, the chances of actually blackouts is increasing, or at least interrupting in the grid system is increasing, so having more security is maybe not a bad move. And lastly, energy storage allows also your operations to further benefit from green energy solutions, because there is that ability to handle the flexibility which you actually need. Of course, there are many different sources of energy storage. The most well known is batteries, of course. We all know them, but they do have a limitation. For really large storage, large amounts of storage, as well as longer duration, they are not very suitable. Subsurface energy storage allows you to deal with really large volumes of energy storage, get the benefits of scale, and for example, think about seasonal variability. That is the place to start looking at this. Energy storage in the subsurface can happen in many ways. It can be green hydrogen, it can be compressed air, it can be actually heat, and you can store it in different type of solutions. Again, with our subsurface expertise, we can help you find the right solution for that energy storage option you might be considering. So those are the 4 different solutions I wanted to highlight. Let's talk now a little bit how to take this forward, and again, maybe step out a little bit on how it fits in the bigger picture. These are 4 important solutions. They are not the only ones. Of course, think about green hydrogen for mobility. I talked about solar and wind, and they are key components of a solution for sure as well. The question is to find the right one for your particular situation. And again, that's where we can help make sure that we evaluate them on the ease of implementation, pending your specific company and capabilities, as well as the impact, again, based on your specific drivers, what really matters to you. To do that properly, rather than making a mathematical simple table of it, you need to start thinking about it in 3 dimensions. You need to really start overlaying all the different elements which make up your particular situation, the below ground as well as the above ground situation, and build a geospatial evaluation of your particular setting, and thereby come up for the right solution for your current operations or potentially future operations. If you want to go one step further, and I think that's the right way to go, is actually start optimizing them, not for one particular solution, but finding the right combination of different alternatives which are there, which is very specific for your needs, your particular setting, to find that ideal mix. And again, of course, you can optimize against your personal drivers. Is it getting as much CO2 stored as possible? Are there financial drivers? Or whatever that might be? Again, we can be very client specific. So let's make it even more practical how to go about this. What we would do and have been doing for clients from fast mover consuming goods to oil and gas companies is starting off with a global screening. Again, assuming you have a global portfolio, that's a good starting point. And there we look at many different kind of locations, different type of drivers, and help to high grade where are the ones with the biggest potential impact. What's the best starting point for your next stage? And from those we can do then a pre-feasibility study in order to understand which of those are again more suitable, leading to a feasibility study which helping you with your particular investment decision. What this particular map shows, again, it is anonymized, is an example of a study which we did for a fast-moving consumer company, where this particular map is specific for geothermal, where we looked at all their factory location and made an assessment on the subsurface as well as the above ground layers to get to an understanding of what is the best ones to take forward, which we're actually doing now with them at the moment and making further detailed plans for that. So you might wonder why Getech, why are we in a good position to actually do this for you? We have been locating subsurface resources for many decades. We have one of the world's leading subsurface databases, which helps that many of these studies we actually can do as a desktop study and carry them out very quickly. We have the combination of geospatial capabilities as well as the geological skills and expertise to make these assessments. And we have the underlying artificial intelligence, supercomputing capabilities to run this. And in addition, as I mentioned, we have the partnerships which actually allow us to make well-informed decisions on this. So to recap, we all know that our future depends on an ability to further decarbonize. Achieving net zero is something which we all aspire for, but we need more practical solutions in order to achieve this. What Getech offers is a set of subsurface solutions in order to help you with this. If you're looking for clean power and heat, think about geothermal, think about energy storage. When looking about how to dispose on your CO2, think about alternative CO2 locations. And wanting to secure your supply chain of critical minerals, again, we can help you to find those additional resources to get that reliability in your system. So in summary, again, Getech is here to help you with your decarbonization journey. We understand the subsurface, so you don't need to. With that, thank you for your attention and happy to take any questions either now or subsequently either at the booth or drop me an email. Thank you.
Hey, we have time for one question if you want to ask. No, not at the moment. Okay. Yes, sure.
Is there a sort of firm number based on the studies that have been done so far for the total potential for geothermal energy providing electricity in the UK?
Yes, so that potential is certainly there. We've also identified locations where that might be done. And I think there's also a need to get clearer regulations in place in the UK to further unlock that potential. We see other surrounding countries which have maybe progressed in that. And I would encourage UK government to make steps in that direction so we can unlock that potential. But it is certainly there.